नो इशू सर. हाँ सर वो भी ले रहा हूँ. हाँ सुधांशु सर will be taking 3 and I'll be taking all the 3. No issue sir, no issue sir, it's fine sir. No issue sir, it's completely fine sir. Thank you very much. Why am I feeling that I am the only person who is lit up here? Need to go one step back. अच्छा क्या हो रहा था? So is my mic off? No, sorry, not mic. Is the speaker off? Yeah. So I wasn't able to hear you people. Now anybody tell me what a SAC means? SACK.
So SAC is a kind of a thing like which used to store things, sir.
You people know thela?
Bag. Bora.
Yes, sir.
Okay.
I know.
Jute bag. Okay, that we prefer now instead of polythene, right? So that can be known as a sack. Okay. Now, why am I telling you this sack? This is something else. So we'll be looking into it in a while. Just remind me 10 minutes before I'll share the information regarding the new question paper pattern. Okay, just 10 minutes before remind me that. It's completely simple. You people have got more time to write now. Okay, less questions, more time to write. Okay, fine. So SCT and ISMS, I was discussing with the girls here that are in the college. We'll be taking the second unit, the remaining part. Okay, that will be taking separately. Okay, anybody from general wants to join that session also, he is most welcome, but those sessions will not be in the college timing. What I want you people to do is that at Sudhanshu sir and I have discussed this thing. DSA won't complete in the sequence that we were trying to complete it. So we'll at least you people will have that idea of what we are learning. So Sudhanshu sir will be taking one part. I'll be taking one part. So if we have extra days, so we can revise it from the very beginning again, right? Right? Fine. So the remaining part of the second unit, what we will be doing, we'll be taking it maybe in the evening sessions, maybe on the Saturday after half day, or maybe in the Sunday sessions also. Okay.
Online or offline?
And that will be online only there.
Okay, sir.
Mukesh,
Then
for
fine.
now it will be online. Okay. For this week, at least it is online. Let's see what happens after that.
Sir,
we are not sure.
then it's completely fine.
Huh?
It's completely fine, then, sir.
Yeah, I understand that online you people are not able to cope up that much with it. Offline it would have been better, but it is fate and Omicron.
It is what it is.
It is what it is. Yeah. Okay, general students, you people are also here. So what we start with is the dynamic programming. It is the from the mid of the fourth unit. Okay, so the topics are not that much interrelated. What you actually need for the other unit is to go smoothly is proper knowledge about linked list, is proper knowledge about how to create a list, right? Proper knowledge about trees. Okay, that part is required there. But what comes after that? There are search algorithms, sorting algorithms, there is dynamic programming, there are greedy algorithms. So these do not need anything as background information, right? So these are completely separate. That's a very nice kid there. Okay. So what is dynamic programming? In simpler terms, we'll try to understand first. Okay. Yeah. Hello. Okay. In simpler terms, we will try to understand what is dynamic programming, right? There are methods by which we resolve issues, by which we solve problems. Okay. Now, what's the problem? Problem simply you can understand as a general life issue, anything general in general life that we want to resolve. That means there's a problem statement. Okay. For example, I want to go to college. Okay, so this is a problem statement. How I'm going to resolve it is the solution. Okay, so that solution is provided by the algorithm. Algorithm part is the steps of the solution. Okay. After that, you are implementing it in the procedure or in the program. Fine. That is completely separate. Now, there are different ways by which we resolve a problem. There is a linear approach. There is a problem. We need to do it. I want to go to college and I'll simply book a cab and come to college. For example, I'll walk on foot and I'll come to college. So these are the methods that we can use. There are other methods also. Okay. There are other methods for problems. There are other methods also for problems where the problem can be divided into smaller parts. Now try to understand. If I want to cook something, just understand this thing. If I want to cook something, okay, I have to cook something. Now I am going to cook it. Then I need, for example, we want to make, for example, a chicken. Okay, we want to make a chicken. So I will need the onions. I'll need the, for example, boiling water. I'll need some spices and then I need the chicken, wash it, right? I need somebody to wash it. Huh? If somebody I'm including, if I'm including somebody in it for washing the chickens, for chopping the onions, for boiling the water, for frying the chicken, right? So if I am dividing it into multiple parts, okay, multiple parts, that may or may not be overlapped in the sense they may or may not be dependent on each other, right? Sometimes it may be dependent, sometimes it may not be dependent. Depending upon that particular situation, whether it is dependent or not dependent, I can use multiple people to do that task, right? Now, if I'm using multiple people to do that task, will it take more time or only one person is doing that task? What will take more time?
Multiple people will take
Less time, na? Multiple people will take less time. Now, why are we using dynamic programming, or why are we using, for example, divide and conquer methods and other methods? Why are we dividing any problem into sub problems? The main reason is that our processors are multi-core now, right? And we have multiple cores, we have multiple processors in the in the
CPU.
computer. So what do these processors do? For example, I have to add 15 numbers, I have to multiply something else, I have to divide something else, and I have to do something else. And these four are different functions that have to be carried out, and these are not dependent on each other. Finally, I have to add their output. So this is a separate work, this is separate work, this is separate work, this is separate work. What we can do, our for example, core processor is there. So that one core will do this process, one core will do this process, one core will do this process, one core will do this process. And finally, we can simply combine these, add one process will be there to add them, right? So if I use only one processor for it, it will be 1, 2, 3, 4, and 5, maybe 5 seconds, let's consider. If I am using 4 processors in it, or 4 sub functions in it, then it is 1 second for these, because these will be working parallelly, and there will be one last operation that will be non-parallel, so 2 seconds for that. So we are saving a lot of time by it, right? Now this is not the only reason, there are multiple reasons for that. We'll look into the reasons slowly when Sudhanshu sir will be reaching on the divide and conquer method. He will be explaining to you why we are using this divisions, why we are dividing it. Now there is another approach, that is dynamic programming. If it was a divide and conquer method,
notes, sir.
huh?
You'll share the notes, module 4. Module
Yeah, I'll be sharing the material. Why are you so much serious about these notes? I already do share the material with you, na? So don't worry, I'll be sharing that also. Okay, people are getting mad now. Fine. I'm getting a lot of calls today. So let's consider what we are thinking now. So there are problems that need recursion. That means there is a process, okay? That process in itself has a child. That process in itself has a child. For example, we have a factorial of a number. So what we do, we multiply it with its previous number. That number is multiplied with its previous number, with its previous number. So what we do, we recursively move towards the end of that sequence, and after that we come back adding those numbers and reach to the end. Now there is one advantage in it. There is one advantage in it. If we recursively do it, we can divide it into smaller parts. For example, we have a factorial of 100. We can divide it into factorial of 100 to 75, then 75 to 50, then 50 to 25, and 25 to 0. Then we can combine those results, right? But we are combining those results again and again. We are using the same approach again and again. We have to compute these, make these computations. What dynamic programming does, it, if the problems are overlapping, if the sub instances are overlapping, we at very first formulate something that can be used for such programs continuously. So there are some particular type of problems for which dynamic programming can be used. So we already formulate a solution,
Yes.
okay, a rough work solution for some problem. And when a such type of problem comes, we try to understand from that table or from that rough work, what should be the solution of this issue, right? So there is a method, okay. Here we need to plan exactly how we are going to solve that type of problem. So we don't have any particular this method for all, we don't have a particular solution for all the problems, but a brief blueprint is there from which we understand how we can divide it into multiple and how it can be applied to resolve that solution. It was invented by American mathematician Richard Bellman. What your issue is that you need to learn some of the problems that can be solved by dynamic program, this programming, not the mathematical background of dynamic programming. That's not required yet. Okay. So it was invented by American mathematician Richard Bellman in 1950 to solve optimization problems. Now, what is optimization problem?
Without complex.
Have you people heard of optimization techniques ever? OT is
Yes,
one of
sir.
the subjects, huh?
Yes, sir.
OT is one of the subjects that was taught early in computer sciences also. It is one of the subjects in UGC NET also. Okay, so this is one of the subjects that you people need to understand also. This is usually more of a management subject rather than this. Optimization technique is how multiple resources, for example, can be optimized for the highest output. Okay, so we have multiple resources. We need to make a tabular form or make a plan how we are going to use those resources so that we can get the maximum output from those resources. So it is like the same. And it was later assimilated by computer sciences also. Otherwise, it's a mathematician issue. Okay, and now it is used by management people to understand, optimize their resources. Programming here means planning. Okay, whenever we will be saying programming, it will be planning only. So main idea is to set up a recurrence relating to a solution to a large instance of solutions of some smaller instances. So what we are going to do, we are going to create small instances of solutions. Okay, now we get a big problem. Okay, I will show the example. I'll show the knapsack example. You will understand. So we have a very big problem. If I already have tabulated its smaller solutions for each step, I have a solution. So by that we can easily get the total solution. We'll solve the smaller instances. Okay, for only once, we'll be solving those only once. Okay, so by that we can simply understand how we can resolve it later. This is a method. Remember this is a method. So this applies to separate problems. Okay, this is not that this method will be applicable for universal problems. I'll solve it once and it can be applied to any problem always. No, but any particular type of problem is there. For example, so I have a particular type of, for example, problem, and for that particular type of problem, I'll have a particular type of dynamic solution. That dynamic solution will be applicable for such type of problems. There is a problem A, then there is a problem B, then there is a problem C. For example, for problem A, I have made the solution. That solution can be again applied for problem B, although the values will change. We will record the solutions in a table, the smaller solutions, and after we have recorded those smaller solutions in the table, we'll simply extract the solution out of it and form the instance from the this solution for the first problem. Okay, theoretically it becomes very much complex to understand what it is and all that, but it practically by example what you will understand, it is very much simpler. Okay, I'll just show you. You will have to excuse me for 1 second, just 1 second.
Sir, 1 second is over.
Okay, so this is the knapsack problem. By this, you people will be a little confused, so that's why I'm sharing something else. Okay, and it will be much more easier to understand by that. Word file. What is the word file? Yeah. Okay, this is the. Okay, so these are 23 pages. Huh? Just mind, don't think that it's a too much of this. This is the whole board work that has been put into this example now. Okay, and on board it will take only 5 minutes. But if such a question comes in paper, okay, you people will have to resolve it by this method only. Okay, remember there are no shortcuts in life. Huh? Is this visible properly or should I increase the size?
No, sir, it is visible.
Okay, now fine.
Yes, sir.
Okay, so knapsack, simply a sack, huh, is a container or a bag. Huh? Simple, you have your bag. Let me give you a simple example for now. Okay, so you people are, for example, hungry. Fine, you people are hungry. Now we have two things to everything. When we are talking about food, there's a price. Okay, there's a price, and no price, not place. You are, let's say it is in our canteen right here. Huh? So there is a price with it. How much cost it will take? Then there is its value. Value in the sense, for example, how much
Quantity?
it is. Maybe quantity. Let's say the size. Okay, that's the size. So there are two values with it. Fine. Now you have some money. You have 100 rupees. Okay. You have 100 rupees. You will first and foremost think how much I have to spend 100 rupees, for example, for the lunch. So what is the maximum that I can get from it? You will think of the profit. What is the maximum that I can get from it? For example, for 100 rupees, there is one burger also. Okay, that is also for 100 rupees. There is one burger that's also for 100 rupees, but you won't prefer to buy it. What you will think? You will think that I should get more of the values, more of it, and the price should be less. What knapsack is? Knapsack is a bag. Simple. So what we think, we take a bag and we think this bag holds, for example, 15 kgs. Okay, this holds 15 kgs. Now, what you would prefer? Simple example. Would you prefer a 15 kg of gold in it or 15 kg of iron?
Gold.
Simple.
Gold.
This is knapsack problem. 15 kg of gold or 15 kg of iron? You will obviously prefer 15 kg of gold. Why? Because 15 kg of gold has more value than the 15 kg of iron. Now you have, for example, multiple bars. There are gold bars, there are iron bars. Huh? Now let's keep the example on 15 kg only. Okay. Let's keep it on 15 kg only. We have 15 kgs bag. Okay. And the gold bars that we have, are of size, for example, 18. No, that much, not that much small. It will be complex to compute then. Let's consider it is 7, 14, 6, 12, 6 kgs. Okay, let's consider it is 6 kgs. 6 kg of gold bar. Okay, you have to put it in the bag. Now you will find the value first, right? Then there are, for example, silver bars also. Okay, there are silver bars also. Now silver bars are of, for example, size 1 kg. Okay, now what would you prefer? 2 kgs of gold bars and then 1 kg of silver. Two bars of 2 gold bars, that will be 6 plus 6 kg in the bag. How much is left? 3 kg. Then 3 kg of silver, for example. Okay, now what if I say that the silver is more costlier than gold? You will use 3 into 5 silver, right? You will put silver in it. There may be instances where there is one item available of multiple things. So what you would prefer? Less weight, more value. Less weight, more value. Always you will prefer that. Okay, so that is actually the knapsack problem. So knapsack is a container or a bag in which we are supposed to have some items. Okay, these items will have some weights or profits. Now we put those items in the knapsack in such a way that it will produce the maximum profit. Optimization again, right? Optimization simply means we want to get the maximum out of it. Okay, so we want to have the maximum profit. For example, weight of a container is 20 kg. We need to select items in such a way that the weight of item should be less or smaller than or equal to the weight of the container. It is not that a container has a capacity of 20 kg and you can put 21 into it, right? It's not the household bags, na? They have capacity of 20 kg and we will be putting 21 or 22 kgs in it. This is computer science. So 20 kg means 20 kg, not more than that, right? So we have selected, we have to select the items in such a way that it should be either smaller or equal to the weight of the container. So maximum optimization will be when it will be equal to 20, right? But maybe now, for example, let's consider we have 20 kg here. Okay, I'll just give an example. How to solve it is something else. Let's say what is we have 20 kg. Now let's consider we have 11 kg of gold bar. One gold bar is of 11 kg. So I'll be putting 11 kg gold bar. Okay. Then we have 10 kg of silver. Silver is not even 10 kg of silver is not equal to 1 kg of gold. Okay, in cost wise. So what would you prefer? Would you prefer 11 kg of gold or 10 plus 10 kg of silver? Aditya?
Yes, sir.
Understand this? We have 11 kg gold bars and we have 10 kg silver bars, multiple silver bars. Now you have come and you want to purchase it. You want to take it, for example. You are not purchasing, you are just picking them up. Now you want to pick up.
Okay,
would you put 2 kgs of silver bar into your bag or simply 11 kg of gold? Because you can't be taking
gold bar, sir.
You will have to
Gold
take
bar, sir.
what you will be taking.
Gold bar, sir.
Gold bar. Why? Because I already told you that the cost of the gold is, even the cost of 1 kg of gold is greater than 10 kg of silver, right? Even though 9 kgs of the bag, 9 kg of the bag will remain blank. It will remain empty, right? Even though 9 kgs of the bag will remain empty, settle there will be one issue that you won't choose silver plus silver to make it 20 kg. We can take this bars of silver and make it 20 kg, but we don't want that. Our bag may remain empty, or our bag may have, not empty, our bag may have smaller this value in it, quantity in it in terms of weight, but in terms of the profits it should be high, right? So now, for example, we have a diamond, okay, and we have a 20 kg gold weight. Fine. Now the diamond is much more costlier. So, but the weight, for example, weight of the diamond is 200 grams. Okay, this is the weight of the diamond. So what would you prefer? Would you prefer diamond or would you prefer 11 kgs of gold? You would prefer diamond only because you would want to maximize the properties. You don't want to maximize the weight. That is the thing that you need to understand. So there are two knapsack problems. One is 0-1 knapsack problem. Either it is in or it is out. And there is fractional, right? So fractional we won't be studying right now. We'll be taking the knapsack 0-1 knapsack problem. The 0-1 knapsack problems means that either an item is completely in or there is no item in the, okay, either there are items in the knapsack or the item is not there. For example, if we have two items weighing 2 kg and 3 kg respectively, if we pick 2 kg for example item, then we cannot pick 1 kg item from 2 kg item. It can't be divided into fractions, right? We have gold bars, these are of 10 kg, that can't be broken into 5 and 5 kg and 14, right? So that you need to understand. So if we take 2 kg item, that has to be taken completely. If we take 3 kg item, that has to be taken completely, for example. So this is 0-1 knapsack problem in which it is 0 times 2 kg or 1 times 2 kg. Okay. No, what's going on? Fine. So 0-1 knapsack problem is solved by the dynamic programming. Now let's move downwards and I'll show you one example. Okay. In fractional part, fractional is again the same thing. We can divide the 3 kg and we can pick parts of it. If we have an item of 3 kg, then we can pick the item of 2 kg and leave the item of 1 kg, right? But this is using the greedy approach. That approach we won't be using for solving the knapsack problem. For solving the knapsack problem, we'll be using the dynamic approach only. Okay. So what's the example, for example, of 0-1? Let's consider weights 3, 4, 5, 6. Okay. So now we have a, see, it is too much simple. Too much simple. Love, it is child's play. You will say, what are we studying? Even our brothers, children know this thing, right? Not that you won't say that my younger brother knows this thing. You will say my brother's children also know this thing. So we have a bag, for example. What's the weight of the knapsack? 8 kg. So whatever you are putting into the bag, it will be maximum of 8 kg only. Okay, just understand it. Now we have weight 3, we have weight 4, we have weight 6, we have weight 5. These are the weights, and we have profits from first 3 is 2, from 4 it is 3, from 6 it is 1, from 5 it is 4. How much we have to populate? 8, right? In general, the number of items is 4, obviously. In general, if we consider it like this without the tabular form, okay, now we may be able to resolve it. These are only 4 items. Fine. Now what if same problems comes with 18 items and 18 profits? It will be very much difficult to tabulate it in mind. So we are not tabulating it in mind, we are tabulating it on the sheets, right? So that is the tabulation method that we are saying. So this is the plan. The above problem can be solved by this method. Okay, so we are setting one. See, we are talking about 0 and 1 knapsack problem, right? Regarding that, see, the above problem, the above are the possible combinations that can be used because we have weight, total weight is equal to 8. This is the manual method. This is the quick manual method. Either we can take 3 kg. How much is left? 4, for example. Then 3 and plus 4. 3 plus 4, 7 kg. We can take 6 kg. That will be only 1, right? We can take 5 kg plus 3 kg. So 5 kg plus 3 kg, this one. Then we can have, for example, separately 5 kg only. Okay, 5, 4. No, this is not correct. This is not correct. The combination is messed up. I have used another example here. Okay, let it be for now. This is the manual method, so we can set zeros and ones. The above, it is the combination. So why 1 will denote the item that is completely picked and 0 is the item that is not picked. Since there are 4 items, did I use 2, 4, 4 and 3, 7? Yeah, I have made the example of profits. I didn't check the weights. Okay, so let it be. We don't need this actually. We'll be solving it by knapsack. So it will be 2 raised to the power 6 2 raised power 4, sorry, there are 4 items, so it will be 2 raised power 4 possible combinations for it. Now that is the same thing that I told you. If this number of items or number of items increases by, for example, 10 only, so we have 14, how many combinations it will be? 2 raised power 14 combinations can be there, whether they are in the weight or not. Okay, but 2 raised power 14 combinations will be there that you need to check, and 2 raised power 14 is a very big value, right? So you won't be able to resolve it by that. What you will be doing, we will be setting a tabulated form by using the dynamic programming, right? Before dynamic, so there are 16 possible combinations for 2 raised power 4. Once all the combinations are made, we have to select the combination that provides the maximum profit. Now it provides the maximum profit, we will be setting it in. After that, we will be looking for the second item that can be put into it, but the weight should be smaller than that. No, the weight should be smaller than the bag, the bag capacity, or maybe equal to it. Okay, up to that only. So another approach to solve this problem is dynamic approach. Okay, now we are looking into the dynamic approach. This is the normal approach that we could have used, right? But if the combinations increase, then it will be very much complex to find all the combinations and understand the profit for all combinations. So another approach will be using dynamic programming. The complicated problem is divided into sub problems now, smaller problems, and we find the solution for the sub problem. When we find the solution for the sub problem, we'll move backwards. Okay, the solution of the sub problem will be used to find the solution of the complex problem. So if anybody asks you what dynamic approach is, this is dynamic approach actually. Fine. So bigger problem is divided into smaller problems. Okay, smaller sub problems. We find the solution for sub problems, and we combine those solutions, and we finally get the solution for the complex problem. Okay. Now we will create one matrix for it. Okay. The matrix you can see 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, for example. In the above matrix, the columns represent the weight, that is 8. This is the weight. Okay, how much you can hold in your bag? Maximum 8, right? And the rows represent the profits or the weights of the items. This one, profits or the weights of the items. So we'll have to consider both the things, profits as well as weight of the items, right? Here we do not take the weight 8 directly. The problem is subdivided into sub problems. That means this was the final weight. Okay, so we are checking for 7 also, we are checking for 6 also. That I already told you that there may be something like here. Okay, 1 and 1 combination. This is a diamond. Okay, this is for example only 1 kg. Okay, but this 1 kg outweighs, for example, the profit that could have been here with, for example, the gold item of 8 kgs. So this won't be the solution. The solution will be here only, right? So we are looking into sub parts also. So the weight has been divided into sub problems, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, and the solution of the sub problems will be saved in the cells, and the answer of the problems will be stored in the final cell. Okay, so first we write the weights in the ascending order, that is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the profits according to the weights are shown like this. See, so this is the weight 3, 4, 5, 6, for example. This is the profit 2, 3, 4, and 1. The first row and the first column would be, it's very much simple now. If you just check it, you have to make the tabular form now, nothing else. Let's take the table down. It's breaking into parts. Okay, so we have weights 3, 4, 5, 6. This is the weight where we can, oh sorry, not this. 3, 4, 5, 6 will be the weight. Size of the bag is 8. This is the first example, na? 3, 4, 5, 6, yeah. Size of the bag here is also 8. Huh? Or knapsack. Huh? You can write knapsack also. The first row and the first column would be 0 because there will be no items for weight 0. Okay, so there are no items for weight 0. What are you putting in the bag? Something that has no weight. If it has no weight, then it will be having obviously no value also, right? Fine. If it has, even if it is having no weight and it is a lot of value, it doesn't correspond to the knapsack problem. Nah? It is completely weightless. Then you don't worry about whether you have to put it into the bag or not, right? So this column 0 and this one will be always 0 0. First row and first column. You can check it at the very first, put it as 0 and put this one also as 0. Okay. Now we'll look forward onto the second. Okay. So down. Bit of my, just 1 second. Okay. Now see, let's take first example. Okay. First example. We'll be setting I is equal to 1, item is equal to 1. We are putting one item and its weight is equal to 1. We have divided the weights from 8 to 0. Okay. The 0th weight is not considered now. 0th weight is not considered, but this row needs to be there for the solution also. Okay. So W1, the first one, when I will be equal to set to 1. So W1 will be equal to 3. It is the first item, right? So you will be putting the first item here. Just 1 second. So W1 is equal to 3, right? Since we have only one item in the set having weight 3, but the capacity of knapsack is 1 for the very first instance. Huh? Just 1 second. This is capacity. There is no item with 0 kg. Let's start from 1 kg. Okay. So the capacity of knapsack is 1 for first time. Now it is of 8 kgs. Now the capacity of knapsack for the first time is 1. Now the question is, if the capacity of knapsack is 1, how many items of W1 can be put into it? The capacity of bag is only 1 kg. We won't be able to put anything into it. See, the weight of this is 3, right? The first item is 3, but our bag is capable of only holding 1 kilo. So it won't be holding anything. It will be 0, right? Now we'll be checking for the second item also. When W will be, weight is same, when W will be 2. Now W1 is W, just 1 second. W will be 2. Oh, sorry, we are not changing W, huh? We are not changing W, we are changing I only. We are not changing W. W will be 1 again. Okay, I'll be 2, huh? So now the weight of the bag is 2. Okay, can anything be set into it? W1 is again 3, right? So we won't be able to put the value in it. It will be again 0. Now let's move forward and we'll see. Since we have only one item equal to 3, knapsack is also 3. Therefore, we'll be find an item equal to 3. Asha, profit corresponding. 1 second. So Wi will be equal to 3 now. Okay. I'll be equal to 1 only. I'm making a mistake here. Just 1 second. Fine. See. Sorry. This is actually confusing me also for the very first time. Okay. So I will be 1. Okay. This is the iteration part. This is the iteration part. I will be 1. This will be the index. Index of W. Let's keep this along with us for the while. Okay. We won't worry about it. So let's keep it with us for the while we do this. Now, for iteration first, for example, for iteration first, when we'll be setting I equal to 1, okay, we are setting I equal to 1 and W equal to 1. Now, W will consider the size of the bag only. Okay, we'll consider it as the size of the bag always. So this will be W. Okay, this one part will be W. Okay, I'll bold it so we can understand this is W. Fine.
Sir, our next class is going, sir.
When?
3:25, sir.
Now, sir.
Yes, sir.
Okay,
Please,
just take one look on it and we'll
sir.
just
No,
okay.
sir, Java sir will lock the room, sir. We are getting late, so they lock the rooms. We cannot enter again.
Who locks room?
Wow.
Jay Mala, ma'am.
We have to join within a 1 minute. sir.
Okay.
They lock-
Okay.
Yes, sir.